Hello everybody, my name is Sean Young. My project was to design a cage for the SeaPerch rover that will be closed by a motor and gear system. It's pretty simple. First, we're going to make a platform on which the cage and all the motors sit, and the platform attached to the bottom of the SeaPerch. And there will be a motor that turns a gear system that we're going to make, and the gears will be attached to the cage. So first we're going to make the cage.
This is a list of the materials and the tools used for the project. Most of the materials I found just at a Lowe's or a similar to store and a hobby shop. And the tools used are just a screwdriver and a glue gun.
First we are going to make the platform where everything sits. We're just going to use some pieces like this, and this will be the main part where these arms will extend out from the platform, and these will be where the cage is held, and we'll have these angle plates that will be where the gears, the shafts of the gears will be attached, and we're going to attach this all together with screws.
This is going to be the main configuration of the platform. This is these arms, and this is where the cage will be, and this is where it attaches to the SeaPerch rover. We're just going to attach screws in different locations to attach all of the parts. Okay, here we have the main platform. As you can see, we have in most places 2 screws to hold each of the pieces together, and so it's stable. And now we are going to use these bent pieces to attach them in 4 different places, and these holes will be used to attach the shafts of the gears and hold them in place. Okay, now we have these pieces in place. For now, we're just going to leave one side of these screws open so we can move it. As you can see later, we are going to move this so we can put in the shafts of the gears. We also have these gears, have the shafts, and we're going to have to force on the gears onto the side so that they are tight.
Now we are going to attach the gears onto the platform of the device. So we're going to slide the shafts into these holes here, and then we're going to line them up so that they will allow each other to spin. And the motor will be the driving force for all of the gears.
This will be the configuration of the gears. In the center we have the motor with the main gear. On each side we have a larger gear with a shaft that ends in a smaller gear. On the right side we also have an intermediate gear that will allow each half of the system to move in opposite directions, so that the cage on this side will move this way, the cage on the right side will move to the left. And I also have just a washer here that holds the shaft in place on this side. As we can see up here, I also attached a screw and a line of glue from a glue gun. This will allow the cage to be guided. We're going to use these linear gears that will attach to the cage. That will move underneath these gears at the end, and that will move the cage towards the center.
Now we're going to take a moment to explain how the circuit of the motor works. This is the motor I have, already mainly attached to the circuit. The motors in here, I already have it waterproofed. I duct taped it and put some plastic over it, and the gear is placed on the end shaft of the motor.
This is a schematic of the circuit. Here we have the motor, and then we're going to have 2 switches. One will allow the cage to close, one will allow the cage to open. So you're going to attach the batteries to the circuit, but on one side the plus terminal will be on this end, and then the minus. On the other side, the plus and minus terminals of the battery will be switched, which will cause the current in the circuit to go the opposite direction.
Any circuit follows the equation V equals IR, which I also have written on the board here, where V is the voltage that in this case will be supplied by the battery, I is the current, and R is the resistance. And the resistance in this case will be from the motor. The more voltage you have, more battery you have, the larger the current will be supplied to the motor, which will cause it to spin faster. And in this case, when we have the voltage reversed, it will cause the motor spin in the opposite direction. So with one switch, it will spin this way. With the other switch, it will spin this way. Okay, when making the circuit for the motor, we'll use the motor, some wires, some batteries, as well as 2 switches. First, we're going to attach 2 wires to the motor and attach it with electrical tape. I've also attached electrical tape just along the way just to hold the wires together. At the end, you're also going to make each of these wires split into 2 other wires just by stripping the end of the wire and attaching metal and then electrical taping together so it is covered. If these 2 wires come from this orange wire, then one is going to go to one circuit and be in series with the batteries and the switch. The other will go to the other circuit and likewise be in series with a motor and a switch. But when you attach the batteries, make sure that when making one circuit, as we saw in the diagram, one side is attached to the plus side of a battery and the other side is attached to the negative. In the other circuit, it needs to be the opposite so that the circuit will go in the opposite direction. And you'll just do the wire in line to the switch, to the battery, and back to the other side. Okay, when it's completed, you need to make sure that each switch will spin the motor in the opposite way. So this switch spins it one way, the other switch will spin it the other way. Now for the cage. When I built mine, I just used some tin plate that I cut into strips as well as some wires, and I hot glued them together in this configuration. You're also going to glue on this linear gear like this, and then the other gear will be attached right here, and as it spins it will move the cage either in or out. And now we're going to put the cage and the motor on to the platform. I just taped the motor on, but however you do it, make sure that it's very secure. And I attached the cage and just slid it underneath the other gears, and so it can move freely.
So that is the completed cage. When putting on the cage, the linear gear will be attached right under the smaller gear. Make sure that these screws here aren't too tight, otherwise the gears will be pulled down. There'll be too much friction for the cage to be able to move because the motor will not be powerful enough to do it. So the motor will turn. We're turning these gears, which will move the cage in and out.
Okay, so that's how you build it. Now we're going to go out and test it. We're going to attach the platform to the SeaPerch rover with some more screws, and we're going to place it in the water and have the cages enclosed around an object so that the SeaPerch can capture and transport that object.